Work it, make it, do it, make sense.
So welcome to Full Stack Scala with Play and Scala.js. Bit about me. So I'm Greg Dorrell. I'm a backend Scala developer at hotels.com. We are hiring. Most of us are doing Java. There's a few teams doing Scala, and I'm trying to kind of get more of us on Scala. Yeah, it's a good place to work, so do come talk to me if you're interested. I started using Scala in 2009. Didn't get to use it in production until about 2012. And about 2 years ago now, I started playing around with Scala.js, and I thought it was really nice. So that's kind of where this talk comes from. Yeah, and I actually got into programming originally by doing like web development, so by hacking together pieces of PHP and JavaScript. Yeah. So today we'll start with an introduction to Play, and then we'll have a look at Scala.js, and then at the end we'll have a look at a little project which combines the two together, and I'll try and explain to you why I think that's really nice. At this point, like, how many of you are using Scala? Okay, almost half, yeah. And like for the others, like, have you looked at Scala, maybe done the Coursera course? Okay, so there's a few people that don't know any Scala. That's cool. So let's start with the Play framework. So who's used Play? Okay, good chunk of the room. Okay, cool. So for those that don't know, Play is a traditional MVC-style web framework for Java and Scala. So Play 1 came out in like 2008, and that was a Java framework. And I remember I was learning Scala at the time, so I remember trying to use that with Scala. That's quite painful. Luckily for me, they rewrote it in Scala in 2012. So Play 2 came out in 2012, written in Scala, but still very much targets Java and Scala. And it's maintained by Lightbend. So do people know Lightbend, the company formerly known as TypeSafe? Okay, so they're the company, the commercial company behind Scala, basically. So they're developing the Scala compiler, Akka, and Play. And the good thing about Play being maintained by Lightbend, it means the docs are really good. There's a good community around it, and you can like go on Stack Overflow and find lots of help for Play. Play is a high-velocity framework. So in the same vein as something like Ruby on Rails, it tries to make it really quick and easy to get an app up and running. It has everything you need out of the box. Like, you don't have to go away and evaluate 5 different JSON libraries and 3 different like RESTful clients. It tries to have everything you need, so you don't have to go and do that. So how do you get started with Play? For those that don't know, in Scala we often don't use Maven. We use like SPT, Scala build tool. And you can use Play with SPT or Gradle. So here's how this is the command you can run to create a new Play project. And I've gone ahead and checked that out. So if we go over here, this is the Play Scala seed. And I can do SPT run. And this will start the app. So if I go to localhost 1000, here we can see the app started. So, yeah, it's very easy to just get up and running and get it started. And the really cool thing about Play is this: it has a really fast, really quick feedback loop. Just hit refresh. So this was what got me into Play at the beginning. Like, it was a Java framework, but it has this really good development cycle. So let me show you what I mean. So if we go to IntelliJ now, so this is the project. So the first thing we can see if you're from Java world is that we don't use the traditional Maven project structure. Like, rather than having like main source Scala, we just have app, and inside here we have our controllers, our views. So let's add a new endpoint in here. So we have this routes file where we configure our endpoints. And I want to add a new endpoint called hello world. So I'm going to copy paste this one, /hello, and we're going to call this hello method on our home controller. So if I go to this controller, I can create a new endpoint, hello, and this is an action or an endpoint, and we get access to the request. So we can like pull cookies off or headers and stuff like this. And we just want to return an HTTP 200, okay, and we just do hello world. So now, if I go back to here, and I go to /hello, it should come up with hello world, if the demo gods are looking down at me. And we can see, you can actually see in here like it's just compiling the files that change. So that took a while, but when we start making incremental changes, this gets really fast. So if I change this like hello devox and go back, just hit refresh, hello devox. So we all know the Scala compiler is quite slow. That's kind of one of the complaints. But you can see that play will just recompile the files that changed. So in this case, I changed one file, so that gets recompiled, and it's really quick. This is what kind of really got me into play. And yeah, I really like that. So if I go back to my slides, I mentioned that it has everything you need out of the box. So there's a good templating library in there, JSON library, dependency injection library, it uses Google Juice. And it's all kind of configured and works well together. You can swap out things, so you're not like forced to use Play's JSON library. And they've also made an effort to pull these out so you can use them outside of Play. So like the templating library 12, it's quite good. Give it a go. We'll take a look at that now, actually. So if I go back to our app, if we look at this index endpoint, we can see what we're doing here is we're rendering the index view. So if we go over here to the views index, and this happens to actually just call another view called main. And this is like a normal kind of template, hopefully not too scary. But the interesting thing here is that we can actually see the input parameters to our template, and they're typed. So our templates actually get compiled down to Scala, and they're type safe at compile time. So like, and that means a few things. So if I like change this to Java util date, then down here on that parameter, I can now get autocomplete, and I can like call all the methods on Java util date. But if I go back and refresh, then that's actually not valid, right? So if you remember, in index we called main, but we've now said in main that we want to receive a date, but we're passing in a piece of HTML. So this gets caught at compile time. So in this case, like if you were developing it, you would see it anyway at runtime if you're using something else. But this idea that everything is in Scala, we want to try and make everything compile time safe, and even the templates do that. So I'll just undo that because it's not valid, and go back to my slides. So we'll have a look at some of the other pieces later on. The other thing is it's scalable. So currently Play is powered by Netty under the hood, and the upcoming 2.6 release will be powered by Akka HTTP. And if you can implement your endpoints in an asynchronous way, return Scala features, then you can actually move away from this one thread per request model. And this is what allows Play to handle a lot more requests than a traditional servlet-based web application. So let's take a look at what I mean. So if we go back to our index endpoint, we're actually going to take this index endpoint and make it asynchronous and change what it does. So I do action.async, and it now complains because it wants me to return a future. And I'll just get rid of the red for now. And I'm going to make a call to a remote HTTP endpoint. So I need to use the web service client. So I have that dependency injected. And now I can do ws.url, and I'm going to use ifconfig.me, which is basically just gives you the your public IP address. And because I just want the IP address without any HTML, I'm just going to pretend to be curl. And now I just want to do a GET request. And you can see that you actually get back a future of web service response. So I want to work on the thing inside the future, so I have to map over it. And inside, I have access to the response. And I just want to pull out the body. So this will be my IP address. And I need to wrap that inside an HTTP 200, as we did for the hello world. So now, if I go back and go to my index page, it takes a bit of time. I have to then remove the null at the end and refresh. Cool. So it'll take a bit of time because it's calling this if config, and that's actually quite slow sometimes. And the cool thing here is that, like, whilst we were waiting, we weren't blocking a thread, right? So this WS client is backed by async HTTP client, Java library, and it's using non-blocking I/O, so we don't block a thread, and Play won't block a thread whilst it's waiting for you to service that request. And this is how Play can, like, scale quite well on one machine. Okay. So although Play is traditional MVC style web framework, where you kind of, generate HTML statically or you generate HTML on the server, it is easy to create a richer front-end experience. So you can easily add, like, CoffeeScript or use a CSS preprocessor to write with, like, less or Sass. And you don't have to go away and learn, like, you can just do this from SBT, or I think Gradle as well. And so you don't have to, like, learn NPM and another front-end build tool. So if you're just adding a little bit of interactivity to your site, this is actually really nice. You can do, like, minification of JavaScript and stuff just from the same build tool. But that said, Play is aimed at traditional web apps, right? So for better or worse, I think the web is headed towards, like, richer, more complicated front ends. And Play doesn't really cover these richer front ends, right? And that's where Scala.js comes in. But Play is good just for building RESTful APIs. So I've used Play on a number of projects where I just want RESTful APIs, and so I ignore all the templating stuff, and it's still really good, just because of this really quick development cycle, and also the ease of deployment. So let's take a look at deployment. Deployment is really simple. So if you're just doing, like, a hobby project, then you can use Heroku, and you can just git push to Heroku, and Heroku will detect that it will detect it's a Play app, and it will just work. Another method which I've been using quite a lot recently is Docker deployment. So let's have a look at how you do that. So if I just kill the app, make this a bit bigger for you. Can you see that? Cool. So now I can do spt docker publish local. So this will build my project and publish it to, like, local Docker. Cool. Okay. So now the Docker image is built, and I can run it. So I can do Docker run. Need to expose it. Expose that port 9000. And then by default, it uses the name of your project, Play Scala seed, and the version you have inside your Gradle or SBT file. So that's 1.0-snapshot. Okay. So that actually failed. If we have a look at why that failed. So the reason this failed is because I didn't set a cryptographic secret. So Play will actually encrypt your session cookies, or it will cross-site request forgery tokens, and for that it needs a cryptographic secret, and it won't actually let you deploy without specifying that in production. So if we go back to the project and we go to our configuration file here, very similar to Java properties files, but we can also do JSON style config as well. And in here I just need to define my Play crypto secret. And this needs to be a nice random string. And now I can rebuild my Docker image. And hopefully I'll be able to run it this time. So if I go back, so I can just refresh, I killed my app. I'm running with Docker, and hopefully it's going to work. Let's try the hello endpoint. Okay, yeah, so we can see that's working. Yeah, so that's how you can deploy to Docker. There's other ways you can deploy as well. The docs are really good, check them out. That's kind of the advantage of it being backed by a big company, is that they have really good documentation. It isn't using servlets, so you can't, one of the things you can't do is like deploy this inside Tomcat or something like that. Okay, so that's it for Play. Maybe at this point, does anyone have any questions about Play? Yeah.
So, what do you think about the feature of Play with Spring 5 coming around the corner with Spring Boot already there? So, do you think Play still has a future?
So the question is, given like we have Spring Boot.
Spring Boot and Spring 5 coming with native inbuilt
Yeah.
reactive programming, which could give pretty similar features.
Yeah.
So, do you think there's a future for Play still?
Yeah. So the question is like, Spring 5 and Spring Boot, they're coming up and they're offering the same features. So is there a future for Play? Yeah, I think so. So kind of the advantage of Play, so Play will be backed by Accurate HTTP. And if you're just writing RESTful services, Accurate HTTP is a great option. The reason you'd use Play instead of Accurate HTTP is that it kind of is bundling all this like stuff together. You get this really quick development cycle, easy deployment, and just you don't have to evaluate a bunch of different libraries. So in the past, I was kind of against these monolithic frameworks, and I kind of preferred micro frameworks where I could compose it myself. But then eventually I got sick of like re-evaluating the latest JSON library all the time. And yeah, so I do think it has a future. I don't think anyone that's using it's going to come off it. Yeah. Anything else? Okay, cool. Let's move on to Scala.js. So, who's used Scala.js? No one? Cool. Who's like heard of it? Cool, okay. Cool, so what is Scala.js? It's a Scala to JavaScript compiler. It was started by a guy called Sebastian at EPFL, which is the university in Switzerland where Scala was first developed. And it started about 4 years ago now. And it hooks into the Scala compiler, and instead of emitting JVM bytecode at the end, we emit JavaScript. And like a big use case for this, of course, is writing web front ends in Scala. And that's where most of the community effort is going. But there's nothing that limits it to just web front ends. So there are people using Play to write server-side, Scala.js, to write Node applications on the server side. There's someone that wrote like an AutoCAD plugin, because AutoCAD uses JavaScript for its plugins. So you can use Scala.js for that. You can use it for Chrome extensions. One interesting use case is like AWS Lambda. So in AWS Lambda, you can run Java Lambdas, but I think JVM startup is like 400 milliseconds, and you're paying per 100 milliseconds. So you're paying, if you use Java, your kind of Lambdas are less responsive than Node, and you're paying more. If you could use Scala.js, compiling to Node, and run that in AWS Lambda. So how do we use Scala.js? It does require you use SBT, so you can't even use Gradle for Scala.js. And what you do is you add a plugin to SBT, and you enable that plugin on one of your Scala projects. And there's two modes you can enable it. So you can have a pure JavaScript project, which is where that Scala code will get compiled into JavaScript, and it will just be one like JavaScript file. And then the other mode is cross-project. So you can have this Scala code be compiled into both JVM bytecode and JavaScript. And we'll see why that's useful later on. And sorry, here's a good point as well to mention that obviously there are differences between the platforms. So just as it doesn't make sense on the server to be able to access the DOM API, it doesn't really make sense on the front end to be able to access like Java OO file. So you can't like take your existing 20,000 line Scala app and just compile it to JavaScript. But what you can do instead is take one of the skeleton projects that's out there. If you go to the Scala.js website, they've got a whole list of skeleton projects. But here's a few. So there's a pure Scala.js project. So this is, if you just want to make a front end only, you can use this. One that we're interested in is Play with Scala.js. and that has like example of like an end-to-end test all the way through. And there's another skeleton for Scala.js targeting Node. There's also ones for like Accurate HTTP with Scala.js, stuff like this. Something that I want to point out is that this isn't like GWT. So who's used GWT or like heard of it? Yeah. Okay, so Google Web Toolkit was an attempt to let backend developers write web front ends without really understanding the web or the JavaScript ecosystem. And that's a very tempting idea, but ultimately it doesn't really work. And Scala.js isn't trying to hide the web from you. It's trying to let you use it, right? So we're not hiding things like React. We're letting you actually use React from Scala.js. So why use Scala.js? Nowadays we're quite used to having the front end and back end often be separate code bases, often with separate dev teams, and that works quite well. That has advantages. But there are some advantages to having one code base with your front end and back end in Scala. So let's have a look at those. So a big one is that you can share your domain model and business logic across the client and server. So I mentioned earlier, you can have cross projects which compile to JavaScript and JVM bytecode, and that means you can have a class and access it both on the front end and the back end. So I work like with hotels at hotels.com, so you can have like a hotel, and you can like get a hotel from the database on the back end, send it to the front end, and use that same class inside like your templating on the front end. Business logic, a good use case there is validation logic. So you want to have validation on the client side to provide a rich user experience, but then you also want to run it on the back end because otherwise someone could just bypass it on the front end, right? And it seems a shame to write that code twice because you've got to coordinate with two teams and implement the same code twice. And also because you could have like subtle bugs in one, right? So you don't want to even have the possibility of the validation being different on the front end or the back end. Yeah, we can even get to the stage where, like we saw with the play templates, they're being compiled, right? So we can actually like have Scala.js templates running on the front end where we refactor something in our DAO that gets something from a database. We send that all the way through to the template, and we refactor it, and it's just done across both the front end and the back end without coordinating between two teams. Another reason is that like you don't like JavaScript and you want something more type safe. You want to catch more errors at compile time. That's a good use case, I guess. For me personally, I don't have anything against JavaScript. I've written apps in Angular. It's quite nice. I don't hate JavaScript. I just I like Scala. And I want to point out that this type safety really goes further than TypeScript. So fundamentally, TypeScript, you take your dynamic code and you can kind of optionally add in types and make parts of your code base type safe. But with Scala.js, your code is like strict and type safe, and you can optionally go dynamic. So there's a feature in Scala that not many people use, the dynamic trait, and you can cast something to dynamic and then call like arbitrary fields and methods that may or may not exist. And we can use this with Scala.js. So if we're using existing JavaScript libraries, and there's no like type safe way of doing it, we can just go dynamic and do that. But generally you can avoid this, and you want to avoid that because as soon as you go dynamic, then you're losing this compile time safety. Yeah, and as I mentioned, even the templates are type safe. So Play's templating library, as far as I know, still doesn't support Scala.js, but there are other ones. So let's take a look at this, Rapture HTML. Let me zoom in a bit. Can you see that? Cool. So this looks a bit weird, but hopefully you can see what's going on here. So I'm creating an HTML document. I've got like a head with a title, and then in the body I've got this unordered list of fruits. For starters, like if I put in like an invalid element, I don't know, Q1, then this doesn't compile because that's not a valid HTML element. But this particular library actually goes further. So in HTML, a list element has to be inside an unordered list or an ordered list. if we take a list element and put it directly inside the body tag, this isn't actually valid HTML, really. And we can catch that at compile time. So Rapture will actually validate that the structure of your HTML is correct. So this is really going a lot further than just string-based templating. And although this looks a bit weird, with like we're calling functions that will generate HTML, this is what React does as well, right? And that's doing quite well. So I don't think that's actually too strange anymore. Okay. It is more mature and production ready than you might think. So it's no longer experimental. It hasn't been for about 2 years. But it hasn't got much adoption. And I think there's kind of a chicken and egg problem. I think a lot of people are hesitant to adopt Scala.js because they don't see many big companies that have adopted it. But this is coming from like a university, like Scala did. It's not coming from like the Googles or Facebooks of the world. They can't just like do their latest social network on top of Scala.js. So something needs to give, right? A few people need to like have faith maybe and like try it because it's pretty good. And until we see more people using it, it's just no one else is using it. Yeah. It already has a really rich ecosystem. So there's a small community, but it's quite an active community. So a lot of authors of popular Scala libraries have made their projects cross-compile to both JVM and Scala.js, and Scala native now for some of these. So these like first three, Scala-Z, cats, and Shapeless, these are libraries for doing strong functional programming in Scala. Circe is for doing like JSON serialization, deserialization. So you can like serialize something on the server, send it to the browser, deserialize it. That's quite nice. And a lot of the standard library works as well. So I said that like there's platform differences, but it's not like nothing works, right? You still have collections, and you even have futures. So in Scala, you have futures, and you can have like a thread pool, and you could run like, you can have like 10 things at once. In JavaScript, we can only run one thing at once, right? It's a single-threaded environment. But futures actually map really well to JavaScript promises. So in JavaScript, whenever you do I/O, it's asynchronous, and you have a callback. And JavaScript kind of realized that was, you get callback hell, and the solution was promises. And that's semantically really close to Scala futures. Also, there's a lot of type-safe facades for existing libraries. So out of the box, there's a really good, you can access the DOM in a type-safe way. We'll see that a bit in a minute. There's also type-safe facades for jQuery, so you can like get autocomplete and all that good stuff. And React as well. So there's a really good Scala.js React library. And that recently came out, version 1. And you can even do things like take a React component from JavaScript and use that inside your Scala.js code, and even define a React component in Scala.js and use that from JavaScript. And also there's a bunch of libraries that have just been built for Scala.js. So Scala tags is a templating library, similar to Rapture, which we just saw. AutoWire is another one, which I'll highlight, which we're going to see in a bit. That one's really cool. You'll see why in a bit. The other thing is that like it's not as crazy as you might think. So Scala.js actually looks really similar to ES6, which is like the upcoming version of JavaScript. So if you have a look at it. Okay. So here is some code. Over here, I have a destination input box, and I have a button. And when I click that button, it's logging something to the console. Let me zoom in a bit. So every time I click the button, it just logs null. And what I want to do is be able to type in a destination and see it logged in the console. So if I was writing JavaScript, I would write this. So I say document.getElementById by ID and get that input box. And then from that, I want to pull the value. Unfortunately, this doesn't work in Scala.js. The problem is that document.getElementById can return any type of HTML element. So input boxes and probably a few other types of elements have this value property, but like a div doesn't have a value property. So we can't do this. So the first way we can do this is we can cast it to an input element. So this, if it's not an input element, we'll blow up at this point, but we're kind of being explicit about it, and it's quite obvious that we're doing a cast. And then we can pull out the value. So now, if I type in London, we can see that I'm logging London. That's one way of doing it. Another way is to go dynamic. So we can get the input element and just cast it to an instance of JS dynamic, and then I can just call anything on that I want. So now I can call that value field, and this will work too. That's fine. The problem with this, and the reason you don't want to do it, is because if I type in some random field name, it still compiles, it just doesn't work. So then we get like undefined, right? And if you've done much JavaScript, you've seen like property blah is not on undefined, and like we want to avoid that, right? So if we cast in the types, like if we do a type safe cast, then obviously this field doesn't exist, it won't compile. So that's kind of what we're trying to do with Scala.js, right? We want to, at the edges, you've got this kind of, you need to cast, but then once you have it in this type safe way, then you can do all your work with it, and then, yeah, the idea is to just push these potential failures to the edge. And also we see that failure a lot sooner, right? We don't like get undefined and pass it on somewhere else and realize later on. So yeah, this is really nice. Okay. So that is Scala.js. Yeah, I'll take questions here. So is anyone, yeah?
How do you test your application?
How do you test it? Yeah, so I guess like how would you test any JavaScript application? Like in general, it's harder, right, than backend. So you could use stuff like Selenium. I think the Play with Scala.js skeleton I have earlier in the slides, you can get the slides online, that has a Selenium-based test, and because Play has that built in. Also, like it's Scala code, right? So you can have your domain classes and business logic in shared code, and then you can just write unit tests with that, right? So, and that's really what you want to do, is you want to move as much as you can into like functional type safe code, and just have a little bit of the edge where like you manually test it, or use like more expensive acceptance testing like Selenium. Cool. Anything else? Yeah. Yeah, that's a good question. So the question is like, how is the Angular support in Scala.js? Honestly, I don't know. I haven't used it. There is a type-safe facade for Angular. Go and give it a try. I haven't used it. Oh. Anything else? Cool. Okay. So now let's have a look at Play and Scala.js. So finally we get to the touch of the talk. Yeah, this is something I started doing like a year and a half ago. I started it for personal projects, just using Play and Scala.js, and I found it to be really productive. So this is the skeleton project I mentioned earlier that Vincent's maintaining. This is a great way to get started. You can just check this out, SPT run, the same way we did with Play, and then hack around on it. But today I actually want to have a look at this little project I built with it. So this is actually a project I use at work. So I teach a course at work to Java developers to teach them Play and Scala.js. And this is the app we built. So I will just change to that project. Oh, kill this. And then it is Scala course. So if I run that, so if we get an idea of what the app does first, before we have a look at the code. So if I go to this, so I work at hotels.com, so it's a hotel listing site. So yeah, we can search by like destinations, and given a distance, we can like see hotels, and Paris is not a good example, but London, So if I change the distance, we can see like the page is live updating. So you can see like there's a bit more to this than just server-side templating, right? So we actually have a bit of an interactive front end. Yeah, so let's have a look at how this works. If I switch projects. So the first thing to notice, compared to the Play project we looked at earlier, is that we have 3 sub-projects in here. So we have this client. So this is the Scala.js code that will be compiled down to JavaScript. This is the server code. So this is, if we have a look inside there, this is our normal Play app. You can see this app folder and the conf where we had our roots file. And then we also have this shared code. So this contains our shared domain and business logic. So if we have a look inside here, we have some model, and there's hotels. So very simple version of a hotel. So we just have an ID, name, lat long. So I mentioned that like we can refactor things and it will do it across the front end and back end. So let's do that, right? So in my ID, I can just rename this to coordinates. And this is referenced in the front end and the back end. They're now just updated, right? I don't have to coordinate across 2 teams. I need some way of getting hotels. So on the back end, when you first load the page, the JavaScript doesn't do anything. It's very common that you want to render initially, at least on the back end, so that it's good for SEO. You don't want to force your users to use JavaScript. But then when the user changes any input parameters, I want to regenerate the search results. So this is the service that I need to be able to access on the front end and the back end. I also have a shared template. So this is the table that actually displays the hotels. So you can see I have like a name, location, images, and here like I'm going through all the hotels and creating a row in my table. Nice thing about this being Scala code is that I don't have to learn how to do like looping over things in my templating language. I can just use Scala code. Also, when I have this creating a Google Maps link, I thought it would be cleaner if I just pulled it out into a separate function. So I can just pull out functions using my IDE. I don't have to learn how to do it in this template language. So if I extract this, I can just call this like render row, and I don't need to know how to use some template language. So I kind of have the full power of Scala, and I don't have to learn as much. Even if it initially looks weird, it actually ends up being quite nice to work with. Okay, so let's have a look at the server. And let's start by looking at the endpoints that I've added. So the one we just saw was this hotel search endpoint, which you give it a destination and a distance. Let's have a look at that. So in here, we have an action like we saw before, and we're fetching the search results. So given that destination and distance, give me the hotels. And then I render this search results play template. So let's have a look at that over here in views, search results. So this is like normal play template, but then down here where I'm actually listing out the hotels with the images, I can use the shared code, right? So this is using that shared code that we saw a minute ago. And then I can reuse that on the client side to re-render whenever the user changes any of the parameters. The other thing to note here is so we're compiling the client down to JavaScript. How does it get loaded in the page? There's a plugin, and we basically just add this line, and then it will be added in. Whilst we're in the server, there's something else I want to look at. So we see this search endpoint, the page that we saw. I've also got this API endpoint. So here is where I'm using AutoWire, which is a library I mentioned earlier. So AutoWire is a library for basically doing RPC. So from the client side, we can call services which are implemented only on the back end, and we can call them over HTTP as if they were available locally. So one of the problems with RPC back in the day, the reason it kind of fell out of favor was because you didn't really know if you're calling something local or remote. And if you're calling something remote, it would block and take a long time. but in Scala we have futures, right? So what AutoWire will do is whenever you call a method on this hotel service, you'll get back a future, and you kind of know that this might take a long time. And this maps very well to like the JavaScript promises. Okay, so let's have a quick look at how this works. So I'm using AutoWire, and it's basically a bit of boilerplate. I have to like create a server, AutoWire server, and AutoWire is agnostic to how you want to serialize your data over the wire. So we're using a library called upickle to do JSON serialization, deserialization. We could use Circe, which I mentioned. There's also ways of serializing it to just byte arrays that we send over the wire. And then down here, I've kind of got to adapt between play and AutoWire. Like at the end, you can see I'm converting it back into JSON and writing it out as a string, and then wrapping it in a 200. But once I have this boilerplate, and I've exposed my hotel service here, in future, whenever I add methods to hotel service, I don't have to do anything. I don't have to update. I don't have to add a new endpoint. It will just be handled for me. So, like, important point: if you're writing RESTful APIs and you have multiple clients, you can't use this, right? So, you want to have that's your contract, right? If you're exposing to multiple clients, you have that clearly defined contract which you manage. But if you have a front end and a back end which are always deployed together, then this actually kind of removes a whole bunch of work. You can just like expose a service and use it and not worry about doing it in two places and having typos or figuring out when you deploy order or something. So this is quite nice. You don't have to worry about backwards compatibility, things like this. Okay, so that's all I want to look at on the server side. Let's have a look at the client. So here I have app. So this is the Scala code that's going to be compiled down to JavaScript. We have a main method here, so much like any Scala class you write, this is the entry point. So when the script gets loaded on the page, the body of main is what will be run. So we're setting up this autocomplete dialog that we saw, like this thing, so we can switch between locations. We are writing these methods to get hold of the distance and destination input boxes. So that's these. And then I have this method to refresh the search results, which we'll have a look at in a minute. And then what I'm doing is just adding event listeners. So whenever you change the destination or the distance, I refresh the search results. So this actually looks quite similar to the JavaScript you might write. So this is the DOM API. We cast it so that we can pull out the value, and then it's nice and type safe. Yeah, and then here, like, we're adding event listeners. This again, standard DOM API. You can use any event listeners on here, any sort of event that's on here. I'm using progressive enhancement as well. So there is a search button, but I'm hiding it if the user has JavaScript enables. Let's have a look at this refresh. So every time you change the input, I capture those values and call reload. So what's reload doing? This syntax is like very Scala specific. So there was a talk in here earlier about which showed this syntax. But basically, we get some hotels, and then we're transforming it into a string using this shared template we saw. And then once that's finished, we are replacing the hotels table with the new version that I just rendered. So hopefully that makes sense. There is a lot of magic here. So this is AutoWire, and there's a few things happening here. So I'm saying I want an instance of hotel service using my AutoWire client, and once I do that, I get access to all the methods on hotel service, which is only search. But I can then call search, and search would normally return a sequence of hotels, but I'm calling it like to a server, so that could be really slow. So AutoWire, we have to add this like call on the end, and at that point, it will wrap our response inside a future. So we might not get this for a while. Yeah, and that's kind of equivalent to doing under the hood. It will be doing an AJAX call and managing callbacks in JavaScript and stuff. But you don't have to worry about that. You can use the nice Scala syntax. And if we have a look at that client, it is, again, we have a little bit of boilerplate. It's kind of similar to what we had on the server side. And so I have to match up the endpoint I have in my roots file, and I have to like take this object and serialize it to JSON, and then deserialize as well. Yeah. So, yeah, that's what I want to share on the client side as well. So any questions about any of the code we just saw? I really appreciate I kind of went through it, and I don't know how easy that was to follow. So, cool, no questions? Yeah, done the demo, so that's it. So we've taken a look at Play and what it offers. We've taken a look at Scala.js. We've kind of seen the status of the project and shown you why you want to use it. And then we've taken a look at Play and Scala.js, and hopefully I've shown you why that's quite a good combination. Any questions? That's the end. Okay, cool.